All right, so this week we're going to work on what they call set theory or set operations. And really what sets are is, we've done joins before. And really joins and sets are very similar in that we're combining data. But the difference is, and I know I mentioned this last week, when we're talking about joins, we're adding data horizontally, we're adding columns. Well, when we work with sets, what we're going to do is we're going to um, do it vertically. We're going to add rows, and they have a lot of commonality, which we'll talk through. The nice thing is, I guess not nice. One of the confusing things about this week that I kind of want to get off right off the bat, and I put this in the announcement as well, is that it's important to know that MySQL doesn't support all of the operators, which is a little interesting. But I mean, they have their reasons, and the reason is that they have Oracle, which is another product that they offer. So anyways, but they don't support all of them. But we'll talk about what each ones of the ones kind of do, and kind of go through some scenarios. The exercises for this week are largely multiple choice. There are two kind of actual exercises, but they're really simple, especially after we go through today's kind of demonstration. Today should be pretty small. So what I'm thinking is we're gonna start kind of small with the content, kind of just try to buzz through it. And then what we're going to do is we are going to cover some of the final projects, because kind of want to highlight some next steps, because if you're kind of on the right track, so to speak, and if you're a little behind, that's fine. But basically I try to, in the weekly announcements, I try to set like a goal. If you're doing the final project, by the end of this week, you should have your database created. So you should have your ERD. You should have forward engineered that using the tool in MySQL that will generate that code for you. So what I'm going to do is I'm going to walk you through how I like to kind of build out, kind of how I like to kind of manage the code on that front, and show you a couple tricks that I think will really help make things easier. So now that we got that out of the way, let's jump straight into the content. So set operations. Really what sets do is we deal with, like I said, the vertical. We're dealing with simply adding rows. Now the key is if we're only adding rows, that means that the columns kind of have to be the same. So we can't just kind of like add rows willy-nilly. Basically the results have to be the same. So as a good example, I'm just going to select everything from customer. And in here we have first name, last name, and email. And then I'm also going to do one from, what is the name of that table? Staff. That's the one. From staff. All right. So you can see we have first name, last name, and email here as well. And then also we additionally have actor. And so we're going to kind of look at these three tables. Now, actor doesn't have an email. So when we get to that stage, we're just going to have to do what we will there. But to start off, just to kind of give like a scenario that would make sense as to why we would use this. Like I said, we have these common columns. We have first name, last name from customer and from staff. So if we kind of want to combine those, we can. And one of the ways we might want to do that is if, let's say it's the holidays, right? And let's say as a business, we kind of want to send out just like a holiday kind of like coupon or something to all of our, not only employees, but also staff. And I'm sure, or not just our customers, but our staff as well. Maybe it's just a generic kind of, card that says, hey, get a free, slushy at Maverick or something, something like that. So the way we kind of do this is we build our first one, and it's really pretty simple. So we're just going to get first name, last name, and email from customer. So here's all of our customers with the relevant data we have here. But now we want to add our staff as well. So what we do is we're going to use this keyword union. And there's a couple variations of this. We have union and we have a union all. And we'll talk about that here in just a minute, but let's just start with union. And we're going to select our first name, last name, and email from staff. Now, when I run this, we actually will have all of our people, including our staff. So you can see down here, I have, we have quite a bit of stuff going on here. We do have this Mike Hillier in that. Just as a little tip, we can kind of add some stuff here. So if we wanted to get some insight into where these came from, I'm just going to say customer as type, and down here, I'm going to say staff as type, because maybe we give them a different coupon depending on their type. Like maybe this is like an automated kind of thing. So here we can kind of see the kind of the source of where this data came from. So for each one of these people, they have a type. You can see most of them are customers, but we also have these staff here. So really what we're doing is we're just adding some rows, even though they're from two different sources, two different queries, we're adding them kind of to the same list. And there's a lot of useful ways we can do this, or why we would want to do this. And we'll go over kind of some of the utility of that next week when we go over, data fabrication. But anyways, to talk more about this specific, our set operations, there's a couple important caveats here.
Brother Kurt, can I ask you a question before you move on?
Yep, absolutely.
Does the second select statement, is that always appended to the first, or does it sometimes get mixed, or is it an always?
So that's a great question. And by default, it will just append. But if we add like an order by, for example, so if I want to order by first name and then last name, it will basically mix these up. So you can see right there, we have our staff up here in the middle now. So
but in the first situation, I could have said, I wonder if it works. So I can just scroll all the way down and go, oh yeah, there's staff.
Yep, exactly.
Okay.
Yep. And then you can also do, just like in everything else, the important thing to remember that if I add a where clause here, so like if I said where, type is equal to staff, this is going to be a problem. Because type doesn't exist because we're just defining it here. But like if I were to say, where last name is equal to Smith, the problem is we're still going to get Smiths in the top section. We just won't get Smiths in the staff section. So it's important to remember that these are still very much two separate queries. So really we're running this. Like if I were to kind of break this off, this is essentially what's running, which in this case, it doesn't pull anything because we don't have any staff with the last name of Smith. So that's an important thing to remember. If we wanted to filter this, you either have to filter before, or if we wanted to kind of do this after, we could wrap this in a subquery where we say select everything from this query where type is equal to staff. And we need to give it a name. So let's just call it T. And there we go. So now you can see we're only getting staff. So basically, it does have its drawbacks whenever you're doing this, but most of the time, what the union is used for, what set operations are used for, is when you already kind of have two data sets and you just want to join them. And there's a lot of like useful ways that this makes sense. In fact, we use a lot of them in the analytics world. So for example, here's a great example. We have data processes that run, every hour, because everyone for their analytics wants real-time data. So we have one data pipeline that's running for the last 180 days. And that's running, every 30 minutes to every hour, depending on how fast things kind of process. So basically it's just continually running. because we want that live up-to-date data, and we want to refresh things because data is changing in real time, or in near real time. So, but then we also have this other data pipeline that is older than 180 days, and we kind of make the assumption that, hey, this stuff isn't going to be changing hardly at all, if any, and so we're only going to run that once a day because it takes a long time. In the 180 days it can run within an hour, but prior to 180 days, beginning of all time, whenever the business started, that can take up to 2 hours to run the data process. So we can't, so rather than be inhibited by the historical data, we can update the near future data frequently. And then when it's all said and done, really it's the same result set, just one's in the near time, one's the historical data. We just do this set operation to union those together, and that way we have all of our result sets, even though they're really in the background, they're really separated. So that's kind of a good example. But let's talk a little bit more about the different types of union here. So what I'm going to do, just to kind of proof of concept this, is I'm going to just kind of fabricate some data. And what I mean by fabricate some data is, rather than say from a specific table, I'm just going to actually select some data. So for example, if I select one as well, let's do this. Let's say, yeah, let's just select let's select Frodo as first name and Baggins as last name. So if I just I don't need a from clause, I can just kind of run this and it'll just give me my one row, right? So let's that's one. Now I'm going to just basically duplicate this to kind of show a point here. So basically, let's pretend that we have two tables that have the same person. So like in this case, let's say I'm a staff member at said video rental store, but I'm also a customer, because who wouldn't be, because you probably get an employee discount. So that's kind of what we're going to simulate here. So let's pretend that this is the staff and that this is the customer. So in fact, I'm just going to throw a comment there, customer and staff. And we happen to have the same person here. So just like we did before, I'm going to use a union here, and I'm going to run this. Now, before I run this, let's have a fun little who can predict the future. When I run this, what will be the result set? Let's kind of have a fun little game. What do you guys think the outcome's going to be? Like, how many rows in the table will we have?
One row.
Okay, someone's done their reading. So when we run this, you'll notice we only get Frodo Baggins once, but even though we just talked about how we're appending rows. So union has this thing, just like joins, we talked about an inner join, left join, and the difference that it makes and how our result set works. This is the same way. So this is with just a plain union. It's going to say, hey, you have two of the same exact row, meaning all the values across all the columns are exactly the same. So I'm only going to show you once. Now that may be perfect. So like in this case, if we're getting like these coupons, and let's say that part of this deal is for everyone we send a coupon to, it costs us, $2. We obviously don't want to send it to the same person twice, because that would kind of be wasteful. So there's this, in that case it works out, but in some cases we might want to see that there's, two, depending on the use case. So we have union, and then we have union all. So now if I run this with union all, you'll notice that we get both. And actually, now that I'm thinking about this, we could just really add a customer as type and staff as type. Let's do that.
Yeah, that was my next question.
There we go. So now that we kind of have these two different types here, if I go back to this, you'll notice I still get two rows because now these rows are no longer identical. And so basically a good way to think about it, if you've already kind of mastered the select distinct, it works very much that way. And if you haven't mastered distinct, well, this is going to be a great way for us to kind of look at it. So right now we have kind of our original result set where we get the two rows, even though they're identical because we're using the union all. But if I were to wrap this in a select distinct everything here, you'll notice I only get it once. That's because the distinct operator basically does what union does, meaning it's going to look for exact identical rows. Now, if I go back and add our types in here, just like before, we are going to get both of them. As type. And what did I mess up here? And sometimes the error messages just make absolute.
Have a semicolon in staff as type.
There we go. Thank you. Perfect. So you can see that we're still getting both, even though we have distinct. So anyways, fun stuff. So anyways, that's union and union all, which is pretty good. So let's move on. So now let's use except. So except is going to work a little different in the fact that we are going to exclude certain records. Basically, it's like saying if I have, these 10 people over here, I want to subtract these people. So if I were to do the except here, and I believe that this one is the one that is not supported. So yeah, so except isn't supported by, or maybe it is. I think it's the intersect that's the one that's not. Maybe it's not. So yeah, there's certain ones that MySQL doesn't support, and it looks like except is one of those. But basically, except is basically like taking one away from the other. So the way I always like to think about it, so you guys are in CIT225, right? And we also, have a lot of other classes at BYU Idaho, such as like the 230 class, or let's say the CIT 111. So just to kind of mock up like a little sample query here, I could select first name, last name from so, obviously this doesn't exist, but let's say that I wanted to get everyone who's in CIT 225. It might look something like this. This is very basic, but let's pretend it's something like this. But then we also might want to know, let's say we wanted to answer the question, how many people are in CIT 225 that haven't taken CIT 111, right? Because let's say we're doing an analysis to see, oh, hey, how effective is this prerequisite, right? So we want to kind of see, like, basically we want to split out those who have taken CIT 111 and those who haven't. And obviously there's ways to get the same data with joins and some other things, but really what's nice is union or set operators can make it really, really handy to kind of throw this together, because essentially it's the same query, but instead of CIT 225, it's CIT 111. And essentially what we would end up with here is all the people in CIT25 minus the people that are in CIT111. So what we're left with is the people in CIT225 who did not take CIT111. So really the except operator is kind of a shortcut. And then there's another one that's called intersect. And it's kind of the opposite, meaning that in this case, like we could, using the same scenario, I want to find all the people in CIT 225 who have taken CIT 111. So with this same query, we could run this once to get all the people who've taken both, and then we can run the one to only find those who without it, and we've effectively split our population only by changing one keyword in our query, and bam, we have both our kind of sample sizes, and we can run our analysis. So anyways, union all, except, and intersect. And again, there's these nice little Venn diagrams out there, SQL set operators, that kind of go through this same thing. Just, I don't like these ones quite as much as the join ones, but they work. So you can kind of see, and this one actually does the joins with it a little bit too. And I wish that they would stack them vertically because it makes more sense to me. Like the way they do this sideways, it screams join to me. But anyways, if you kind of turn that sideways in your brain, so you realize that they're adding rows and not columns, you can see that like if we do a union, it combines rows from both queries. Intersect keeps only the rows common to both queries, so just the middle, and except excludes rows from the left query that are included in the right query, just kind of like we talked about. So those Venn diagrams are pretty nice still. I really like using those. Any questions on those before we switch gears to the final? Alrighty, let's do that. So I'm going to open up a model here real quick, if I can find it. So we're going to use my family cookbook thing here again. All right, so here's my family cookbook. So let's say you're working on your final, and you know we've talked about how to go through and build all this, build our relationship, so we kind of have a nice little model here. And this is the nice thing, is this is one of our deliverables. So we do this and bam, there we go. And the amazing thing is that we can use the tool. We've pretty much, if we've done this right, you know, if we have everything connected properly, we can just kind of generate all this code for us. So what we can do is we go up here to database, and then we go to forward engineer. And this is pretty cool. So basically you put in your password and stuff because you can actually have this kind of make it for you. But I'm gonna not have you make it for you, and I'm gonna tell you why once we get there. But inside this section, just a couple things I really like to do. This drop objects before each create. Definitely want that checked. Omit schema qualifier and object names. We want to check this. Leave that one blank, leave that one blank, include model attached script. Okay, perfect. So basically we can just check those two additional columns or check boxes and hit next. And we'll go over what those mean here in just a minute. So then we pump in our password here. If we get it right, really doesn't matter. So maybe it does. There we go. All right. So then we hit this point where we kind of have this code here. Now you guys haven't really seen like create table stuff, but it's all here for us. So this basically is going to create our tables for us. So what I'm going to do at this point is I'm actually going to copy to clipboard. And at this point, once it's copied to clipboard, I'm just going to hit cancel. And then what I'm going to do is I'm going to go back to my just general editor. And I'm just going to open a new file and I'm just going to paste this in there. So just Control V. And here's all my code. So I have step ingredient, measuring unit, ingredient, everything's kind of in here. And what I'm going to do is I'm just up here at the top of the file. I'm just going to add a statement that says use something. And I guess I'm missing a step. The first thing we should do, let's do a new SQL script. Not open. Let's just do a new one. So the first thing we want to do is let's create our database. We can name it whatever we want. So I'm going to say create database. And what's a good name for a cookbook? Let's say I want to theme my recipes, or I guess it's a family cookbook. So I don't even know. It's a little play on words here. So I'm just going to create a database, House of Cooks. And that's going to be like, let's say that's the name of my product. So we can kind of name the database whatever we want. Obviously, it's got to be like table names. So underscores are always good to use. So we can just run this and you'll notice that it's there. And as soon as I run this, I can right click over here and say refresh all. And now you'll notice that it popped up here. We have this House of Crooks database that just kind of showed up, but it doesn't have anything in it. So the database is kind of there ready for us. So now what I'm going to do is I'm just going to say use House of Crooks. And if you miss this step, it's going to build all your tables like in Sql or somewhere else and just becomes messy. But what this is going to do is now we have this script here that's going to basically build everything for us. And what's really nice, why I had you check that checkbox to make these lines, is every time we run it, it's going to delete everything and recreate it. Now that might scare you, but hold out on me here. So now all I have to do is, I can just click this, run the everything. This little lightning bolt without the cursor is just going to run everything. So if I click this, and I typoed something, House of Cooks, not Crooks. That's the play on words. So let's try that with the correct spelling. So now if I click this, it actually runs through. And again, if I right click in here and click refresh, or there's this little button up here and click that, now you'll notice that I have all my tables in here. And what's cool is, let's say that, oh, I want to rename my column. Instead of like on family, instead of name, I want family underscore name, just as an example. All I have to do is click this button and bam, hit refresh again. And now if I go under family, now instead of it just being name, it's family name. And so you can see that makes it really, really fast and easy to kind of like keep your code clean, versus rather than having to go fix your ERD, regenerate the code and all that. Because honestly, it's easier to just change it here sometimes, especially when we start talking about foreign keys and stuff. So anyways, and then from here, if I wanted to fix my ERD, I can just do the reverse engineer, click next, type in my password and next, and I want to do this for House of Cooks, and it does its thing. We execute it and done. Here's my ERD, and we can just, straighten it out. So anyways, pretty cool once you kind of have that. And the reason we do that is because we can fix things very easily, because once we start putting data in here, which is going to start being the next steps, things get more difficult to do, because we want to be able to, like for example, if I want to change something, I want that effect to happen and all my data to come back in. So what we're going to do is I'm going to save this file. Well, first what I'm going to do is I'm going to make a new folder. Wherever you like to keep your projects is what I would recommend. So what I do is I put mine in this samples folder for now. So what I'm going to do is I'm just going to create a new folder. And I'm going to call this House of Cooks, or you can call it CIT225 Final, or whatever you want to call it. Basically, this is going to house all of my resources for the final project. So what I'm going to do is let's create a new folder, and I'm going to call this one lib. And basically that stands for library, pretty common naming structure like amongst programs and stuff. So I call it lib just because it's these are going to be little useful things. So now that we have that folder, I'm going to go File, Save, Script As, and I'm going to go to my documents here, my samples, and then inside the House of Crooks and lib, and I'm going to name this create schema.sql. And basically what that means is it's going to create our tables for us. So this is our create schema.sql. And the nice thing is at this point, once we hit save, we could make this database wherever we wanted, or we could duplicate this wherever we wanted, which I'll show you here in a little bit, how we can kind of have like a dev server if we wanted, or a dev database. But anyways, now that that's there, we have this create schema. And what I'm going to do is I'm going to create another file. We're going to use House of Cooks. And this one is going to be called our seed script. So as part of our seed.sql. So as part of our project, we need to have data in there. And these will also count as your CRUD statements as well. So the C in CRUD stands for create, which is really just an insert statement. And so as part of this, we need to put at least one row of data in every table. Now, that can become a little tricky because we have dependencies. So really what we want to do is we want to kind of take a look at our data and kind of find like where the data starts. And this will be easier for you because you know your project, and just like I know mine. And so just by kind of looking at this, I know kind of where my data starts. And really what we're looking for is on our little lines, if something has these caret feet, like family member, that means that this depends on system user. And so we can't insert a family member until we have a system user to tie it to. So in this case, if we're looking at system user, notice how it has all these like little double lines. That means that it doesn't depend on anything. So we can insert into system user right now. We could insert into ingredient type, and we could insert into measuring unit. Those are the only ones we can insert immediately into first without having other data. So I'm going to start with system user. And so what I'm going to do is right click on system user, and I can just say this generate SQL or send SQL to editor, or copy to clipboard. Sorry. So there's this copy to clipboard and there's this insert statement. I'm just going to go ahead and click that, paste it in, and bam, like all I have to do now is fill in the blanks. Now, the one thing that's kind of annoying with doing this is if you've done things right, your ID key, your primary key, should auto increment, which means we don't need to worry about it. So I usually just come in here and delete that right off the gate. And if we're being honest, so at this point now we can kind of just fill this in, like, oh, what's my email? Well, it's Tanner@fakemail.com. What's my password? You wish. And then, you know, we can kind of put all this in here, like for the created app. Now, the other thing is if we've done this right. So if I take a look at my system user table, I can either look in my script now, and you'll notice on created at, it has this default current timestamp. And then also over here, if I look at my columns, over here in the default current timestamp, that's perfect. So that means like on this, since it's just telling me when it was created, I can actually just delete that column as well, because it's going to handle itself. You know, when I created it, that's what time it's going to show. And then first name and last name. So just like that, 1, 2, 3, 4, 1, 2, 3, 4. There we go. So I have a create statement for my system user. I can go ahead and run that. And now if I were to select everything from system user, there I am. So that worked perfect. Now what we're going to do is we're going to leave that just like that. And we could keep going down the line. So looking at my model again, if we wanted to do another, let's say, and this one gets a little tricky because family members depend on both of those. So let's create a family. So now I'm going to say, I'm going to do this one manually. So I'm going to say insert into family, because the one thing that I also don't like is this. Let's take this out. Because we're using this, we want to leave this blank in case we want to populate this test data in other databases. Because then if someone creates like House of Cooks dev, it's going to say, oh, you're still going to insert into the House of Cooks database, even if because it has that database qualifier. So we're going to insert into family, and I'm just going to pop this open so we can take a look in what's in here. And I'm going to insert into name and owner user ID, and values is going to be family and the owner user ID. And here we can just kind of, if we really wanted to, I know my user ID is 1, so I could put that in there, but that may change. So if you wanted to play it safe, you know, we could use a select statement. But you know, let's just do 1 for now. And we're just going to go ahead and pop that in there. And now we can do select everything from family. What did I do wrong here? Oh, I just hit the wrong button. So there we go. So we can see that there. Perfect. All right. So we keep going on and on down the line, and we're going to save this one, save script as, and this one would be called seed.sql. And seed basically just means like populate the database. So kind of fill it with data. So that's going to give us our temp data. And then, you know, we keep going on down the line until we had a row in each one of our tables. The last little thing we want to do here is clean up, because now let's say I want to erase all my data, but not necessarily. Well, let's just do this, because technically we can keep our data in there. So let's just create a new script here. And what we're going to do, well, actually, let's do this. So we're going to call this rebuild.sql. And what this rebuild.sql is going to do is it's going to actually call these other 2 files to work. So what we're going to do is I'm going to type in source, and I'm going to say the first thing we want to do is create schema. Create schema.sql, and then we're going to source seed.sql. Now you'll notice that this is throwing an error, and that's fine because it really wasn't meant for this. But I'm going to save this script and we're going to call this rebuild.sql. All right. So now inside of our lib folder here, if I were to right click and open a terminal, do this from command line. So MySQL -u -p, whoops, MySQL -u. There we go. Oh, and I guess I need the right username. There we go. So now I'm in here, and you have to be in the folder where you launch from to make this work, because now we're kind of in this working directory. But now if I were to say source rebuild.sql, you'll notice that everything worked here, and it actually just ran all of these for me. So I can run this over and over and over again, and it will rebuild everything. So let's say that I goof up and I want to just start fresh, but without having to retype all my code, I can very quickly just rerun this script and kind of be there. So for example, let's say I'm not going to save this, or let's just make a new file. So like, let's say I'm doing something and I say, oh, I realize that I need to, or I accidentally say drop table. What's the one that's a root one? If I drop table step ingredient notepad, trying to think of what I can drop here, because most of these will scream at me. Ingredient, step ingredient. Yes. So let's say I accidentally drop this table and then go, uh-oh, like I wasn't supposed to do that. Well, good thing I can just do this and it's all back. So basically I like to kind of put my scripts together that way. At least the create schema and the seed script. The rebuild just a nice little thing to save you a couple clicks and buttons essentially. But I like to kind of keep that in a lib folder. So that way it's all there too. So you can keep kind of doing this. So that's your lib folder. And eventually what you'll end up having is let's see, you'll have a crud.sql testcase.sql, and you'll have a PowerPoint. And I know that's just a text folder, a text file for now, but you kind of get the picture. So you'll have that, and then you'll also have your model. So like if I wanted to export this, there's a couple things I can do. I can say file, export, save as a PDF, save as a PNG. I'm just going to export as a PNG. Documents here, samples, House of Cooks. I'm just going to save it here as erd.png. There we go. And now we have this. So really at the end of the day, your final project, if I were doing it, would look like this. I have my PowerPoint, my test cases, my CRUD statements, and then inside of here, I have all the stuff needed to kind of rebuild my database from scratch. And yeah, that's kind of how I would do it. And that way, if, and just so you know, last term was the first time I kind of like went through this in detail, kind of like how we just did with setting up your create schema.sql, your seed.sql. And there was a lot of students that actually said, hey, I'm glad you had me do that because I ended up using it a lot and it saved my life a few times. Because there's actually been people that they'll just work off this. They'll just do everything here, and they never generate that file. And like this file gets corrupted, or they lost this file or something. And that's problematic. And so obviously back up your files regardless of how you're doing it, just to be sure. But also this makes it nice because this is in code form. And so then you can use things like Git if you really wanted to, which is always kind of nice. But any questions about this or concerns? We'll talk more about like the test case and CRUD statements next week, but I really wanted to go over this in case you kind of want to get started filling in your every table have a row of data. I think that's a great next step once you kind of get to the point where you're here.
I'm just glad this is recorded.
Yeah. So yeah, sorry, moved a little
Same
fast,
here.
but yeah, definitely go back and rewatch it. And if you ever have any questions, just feel free to ask. All right. Any other questions? Comments, funny jokes? All right. Well, I will give you guys back 10 minutes. Thanks for being here. And again, if you have any questions, feel free to reach out.
Thank you
Thank
very
you.
much.
Yep. Thank you.